Good morning, and thank you for joining the Mackinac Center for our latest virtual event, Texas Energy Crisis, a wake-up call for Michigan. My name is Caleb Portop, and I serve as a Director for Strategic Partnerships for the Mackinac Center. We encourage all of you to submit questions in the Q&A box at the bottom right corner of your screen. Feel free to submit those questions throughout the event that you have, and we will address as many as we can after our main presentation. Those we don't have time for, we will address via email. I believe we all have emails for those who registered, or by another means. If you have a question, feel free to reach out to me, and I can direct that to other members of our team at a later date. Thank you again for joining us, and I will begin by passing off to Mackinac Center President Joe Layman, who will provide a brief update on current priorities and work at the center. Joe?
Thanks, Caleb, and welcome everybody to today's show. We released a report just in the last few days on the cost of Michigan's second lockdown last year. And there have been some other reports, or I know of at least one that is out there, that really tended to review some of the benefits of the lockdown. And there are benefits to the lockdown, but ignored a lot of the costs. And our analysts do, I think, a pretty good job of looking at both sides of the equation, and we'll be featuring that report in a special program by video next week, just like this one, and I believe my colleagues will have more to say about that toward the end of today's program. Last week and this week is exciting for the Mackinac Center for another reason. We have moved into our new Freedom Embassy in Lansing, across the street from the Capitol building. We occupy 2 floors in what used to be known as the Farnham building and is now called the Louis. But the 2 floors we occupy are the Freedom Embassy because we share that space with other freedom-minded groups dedicated to advancing policies that the Mackinac Center has stood for a long time. Friends like Americans for Prosperity Michigan, the Great Lakes Education Project, the Freedom Fund, Michigan Rising Action, and I hesitate to name them because I've surely forgotten one or two. But our government affairs team is headquartered at that Freedom Embassy across the street from the Capitol. We moved our satellite office into the Freedom Embassy a week or 2 ago. But headquarters for the Mackinac Center remains in Midland. Although the allies we're partnered with in Lansing, they remain headquartered in Lansing. We'll be having an open house when it makes sense to do so that we can follow the laws and restrictions as closely as possible and not endanger anyone unnecessarily. But I wanted to pass along that good news to you. Another piece of good news that I got just by reading email at work is probably something that you all haven't seen yet. And this is related to our analysts and my colleagues having foresight into seeing what might the federal government try to do in terms of sort of dictating states' agendas by dangling money in front of the states. Well, of course, that is happening now in turbocharged fashion. President Biden is really vigorously pursuing a $2 trillion package that he calls infrastructure. There's a lot in it that doesn't seem to be infrastructure, but the $2 trillion of borrowed money will be in it. And one way or another, this will probably be flowing to Michigan in a huge quantity, and some of it prescribed to be spent on rollout of broadband in areas where there isn't very good broadband in Michigan. So here's where my colleagues had foresight. Last year, they worked with legislators, and the legislature passed, and the governor signed a bill that says any build out of broadband will not be done by government entities like so many cities have tried to do in Michigan and tried and failed to do. It'll be done by private entities, and it'll be subject to a competitive bidding process. So if we can't stop the borrowing at the federal level and the sending the money to the states, we can at least make sure that some market incentives come into play and that local governments don't use this as an excuse to expand permanently. It would be one thing perhaps if these local governments had done a good job with their broadband projects, but almost none of them have. They've rolled out expensive projects that are over budget, they're late, and then people don't sign up for them, and so they just don't have the expertise. So that's a little inside information about the Mackinac Center's role that won't make the headlines. We continue to pursue information in court from the state about how the governor has handled her nursing home COVID policy. We're all aware of just the disastrous policies and the attempts to hide data from the public in the state of New York and Governor Cuomo. And our governor had similar policies, and her administration has just been reluctant to show the underlying data. And we really think that the public needs to know. So we're representing journalist Charlie LaDuff in pursuing that public information in court. And I can't recall a case where we have lost in court in the pursuit of public information. So I'm hoping we keep our streak alive here. I want to thank Mackinac Center supporters for being there with us every step of the way. And I hope you enjoy today's program. Caleb, back to you.
Speaker this morning is Dr. Brent Bennett, who hails from the other Midland. Joe mentioned our headquarters at the center is in Midland, Michigan. Dr. Bennett comes from Midland, Texas, originally. He is the policy director for Life Powered, which is an initiative of the Texas Public Policy Foundation with the objective of raising America's energy IQ. And our second speaker this morning is the Director of Environmental Policy, Jason Hayes, here at the Mackinac Center. He spent more than 3 decades studying and working in environmental and energy policy, has a strong background in those fields. And without further ado, I'd like to move forward with our discussion with Brent Bennett and Jason Hayes. Now, I'll start off with Brent. I'll give each of you the chance to go back and forth and have a conversational format as we've done in the past. And Brent, I'd like to start with this question. It apparently wasn't sufficient for Texas to go through the February 14th through 19th weather event and associated blackouts. Just in the past week, Texas regulators at ERCOT issued conservation orders to encourage Texas citizens to reduce their energy use, with Texas utilities were producing 3 GW below the day ahead forecast for energy demand.
Hear me all right? Oh, there we go.
Yes.
Just off of mute. Great. No, thanks for having me, Caleb. And yeah, it was interesting last week because we were talking about in the House State Affairs Committee our shortage of dispatchable capacity. We were, on the verge of having a conservation alert. So it's funny how that cropped up in April. And really the problem is that we have a lot of generators offline right now because they're scrambling to get ready for the summer, get all their maintenance done. There's catch-up work from February. And so there's, the demand wasn't very high at all, but we had a lot of generators offline. And then the wind, there are times when the wind doesn't blow in the spring, even in Texas, and the wind dropped off on that day, and here we are, right? So it's just a sign that our grid is becoming increasingly difficult to manage, and it's very hard to plan for the variability that we're starting to see. You already have variable supply, or you already have variable demand, and now we're seeing very much more variable supply, and it's just making things really difficult. So it was quite telling.
Absolutely. And Jason, I don't know if you have anything to add to that. I know we do have a second question here too, so you have opportunities to address anything you'd like to on the front there. But in mid-February, the Mackinac Center published several articles and appeared on several podcasts and radio shows to discuss how the Texas blackouts related to Michigan's energy future. What situations has Michigan encountered that were similar to the recent instability that Texas experienced, and how can we work to avoid similar blackouts?
Yeah, so building on what Brent said, actually, first, welcome to everybody who signed in, and thank you for joining us for this event. But building on what Brent said, um, the issue really is that as we go more and more to variable sources of electricity like wind and solar, we're kind of we're putting ourselves more and more at the whim of Mother Nature. So when the wind is blowing, we will have electricity. When the sun is shining, we will have electricity. When it's not, then we're kind of left without. And so more and more Michigan is moving in that direction. And for an example of a time that we encountered something similar to this was in January 2019 when the polar vortex event hit the state of Michigan, really all of the Midwest, but hit us. What happened is the temperatures plummeted. We went down to negative 20 Fahrenheit and that. And across the Midwest, there was an issue when it was in places like Minnesota and that, where it went below negative 20. Even the winterized turbines, the wind turbines, were not able to operate at that extreme cold. And so what happened is some of the wind turbines shut down because of the extreme cold. Others shut down just because there was literally no wind blowing. And so at times when it was down around negative 20 and that, we had wind producing, 1% or less of our electricity in the Midwestern region. It's called MISO, our independent system operator that oversees our electricity. In the region where MISO, or where we are, we had less than 1% wind, and solar was down even to negligible amounts below that. And so throw in on top of that the fact that we had a fire and an explosion at the Ray compressor station, where a lot of our natural gas resources are kind of corralled and shipped out across the state. And so what happened is we had a situation very similar to Texas, with increasing demand because of extreme weather, and then a sudden loss of natural gas supplies. And so we all got the text message at around 11 o'clock at night that said, everybody turn down your thermostat to 65 or below, because if you don't, we could have a system failure. Okay, well, the difference was Texas didn't catch it in time, so ERCOT didn't send out that conservation warning, and so they did have the system failure, and so they had rolling blackouts and that sort of thing, and we came very close to that. And the thing that saved us here in Michigan was we still had lots of nuclear, lots of coal, and lots of natural gas. And so during those times, coal, nuclear, and natural gas produced 75–80% of the electricity, or even more of the electricity that we needed at that time. But the big utilities are planning over the next decade to 2 decades to close much of that coal, one of the nuclear plants, and a bunch of the natural gas. And so we're putting ourselves very quickly into that exact same situation as Texas just experienced.
Now, my next question here is for Brent. We'll go back to him. The Dallas News recently published what was described the Texas legislature considering legislation that would require renewables to cover the cost of their ancillary services. How does requiring renewables cover the cost of transmission, or ensuring it has sufficient power, like natural gas and battery storage, the backups that Jason mentioned Michigan has? And how does that ensure a more stable grid?
Yeah, the problem in Texas is there's kind of three. We have an energy only market, right? So we're paying for energy, we're not paying enough for reliability, and the way our system is set up is to manage, variations in demand, right? But with a supply that we can ramp up and down, right? So we have pricing mechanisms, we have ancillary services to ensure that we can ramp up and down, we can manage some small shocks to the system, right, to supply, but we don't have enough really to ensure that we can manage against the variability of wind and solar, which varies as much as demand now. We have, 30% of our installed capacity is wind and solar, right? So that adds another layer of variability on top of variable demand that we have to manage, and we're not doing it. We have nothing in our market that really is built to manage this. So we've kind of been, there's kind of three ways you can go about it. One is what we've been doing, which is to not pay for anything, and we pay for the reliability costs on the back end with frequent and more severe outages. We've dodged outages each of the last 3 summers, just been lucky, frankly, that we haven't had anything. And then we happen to have summertime levels of demand in the winter, and here you go, right? In addition to all the generation problems that we had, which made it even worse. So we're now going to pay for that on the back end, right? I mean, we have billions of dollars in bills that we have to pay now because we lost power. The other option is to socialize those costs, right? And so we do that with a lot of costs right now. In Texas, we transmission and a lot of grid services are paid for by fees to customers. And we did that when we set up our market because we wanted to encourage generation to come into the market. So we don't want to make generators pay for some of these costs, right? Even though they're imposing those costs on the grid, right? So that's one way we can go. And that's going to, if we want to have more wind and solar, that we can start to do that, right? We can just have customers pay for those costs, right? But the problem is then you're going to have, those costs are just going to escalate, right? The more wind and solar you have, the more backup power you're going to need, the more services you're going to need, more transmission you're going to need. So it's probably it's going to be a lot more expensive for customers to do that. And so if we want to pay for those costs, then in that way we can, but it's going to be expensive. The only way we can really balance the market is to start making the generators pay for more of their transmission and reliability. And that will force them to balance out, right? So if we make wind and solar approach closer to the reliability of gas, nuke, and coal by requiring them to provide backup power and to provide ancillary services, ramping and reserves and so on, then that'll start to balance the market and take out some of those implicit subsidies that we currently have for generators, right? So this is a much better market design, and we think will ensure more reliability, more balance in the market. We still have the federal subsidies to deal with, but at least we can take out some of the implicit subsidies that we have right now and actually start paying for some of the reliability that we're not paying for right now. So that's what we're hoping to see more of out of the legislative session over the next few weeks.
And to build on that just a little bit, there's discussion that keeps coming up, and people say, well, you can close down the natural gas, you can close down the nuclear, you can close down the coal, because all we need to do is just build batteries. And okay, there was a study that was just released by Mark Jacobson, who's a researcher out of, I believe he's at USC, but a California-based academic. And
he's at Stanford.
Okay, at Stanford. So his study just came out, and he said, yes, it's possible to go to 100% renewable, and he was speaking specifically about the Texas market. And so, okay, good, we can go to 100% renewable. How much batteries capacity would we need to make that happen? So Jacobson came up with the number 7,000 gigawatts of battery power. So to give you an example of, like, this is a massive amount. For some of the biggest nuclear plants in the country are 2 gigawatts. So these are plants that have cost billions of dollars to build and will operate for 80 years plus, but they're 2 gigawatts, and they will power an entire city pretty much. Jacobson said we could go to 100% renewables by building 7,000 gigawatts. So the numbers are astronomical. And honestly, Brent will be better talking batteries than me, because that's his specialty. But I mean, I'm sure I see Brent smiling when I'm bringing up this study, so I'm sure he has seen it. But the numbers are fantastical.
And that ties into our next question, which I'd like both of you to address. How does requiring renewable energy to account for the cost of these ancillary services like transmission, load balancing, load following, help ensure that energy markets are pricing and the service of electricity properly, that there's proper pricing?
I'll let you start, Brent.
Yeah, no, that kind of ties back to what I was saying before, right? Which is if you want to have balance in the market, then you need to make generators pay for some of these costs. If you socialize the cost among consumers, then there's no balance there, right? You're just gonna subsidize whatever comes into the market with energy and not make them pay for some of the costs that they impose on the grid. Right? Sorry, I accidentally muted myself. That's the idea, is to provide some balance, right? Now, to go off of uh, what Jason was saying earlier, we've actually done some of our own studies to see what it would take to make Texas go 100% renewable, and we actually found a lot less battery storage than what Jacobson found. He actually said more than what we did, even though he's an advocate for this kind of stuff. It's remarkable. So just to give you an idea of how much 77,000 gigawatts is, our current installed capacity of thermal generation, gas, coal, and nuclear in Texas, is about 70 gigawatts. So it's like 100 times more battery power than what we currently have in terms of power plants in Texas, right? And so, and the reason is because you need several days of energy storage to
Right.
cover your demand in a lot of cases, especially in the wintertime. In Texas, we have a balance of resources that allows us to get by in the summertime with less energy storage, because the wind and solar kind of balance each other out, which Texas is somewhat unique in that perspective. Michigan doesn't have that as much, right? And we also have our highest demand in the summertime, so that's also different, right? In Michigan, I think the numbers would be, on a relative scale, even far greater, because your highest demand comes in the winter, and which was when you have no solar, and so it's really just saying that's just for Texas. The challenges for other parts of the country are even greater.
Right, yeah, Michigan, in the winter, Michigan solar actually will go at sometimes, like in January, will go down to 4 to 7% capacity factor, which means that if you take the total amount that something can produce, the nameplate capacity that something is rated to produce, and then divide that into the actual hours that it's producing, you get kind of an idea of what capacity factor is. So at 4% capacity factor, a solar panel would be producing electricity for maybe 2 or 3 hours a day. So you need to, if you're going to build battery power to supply when the solar panel isn't producing, then you need to be providing enough power for the other 20 plus hours. So that's just to get one day, but in a lot of cases you have situations like the polar vortex, where we had 3, 4, 5 days of extreme cold, where it was very cloudy, where snow was falling and that kind of thing. It's covering over the solar panels. So those batteries have to be fully charged and ready to go when the storm hits. And then they need to last for as long as the storm lasts. And you're hoping, like mad, that in the interim, the wind will kick in or something like that, and it will be able to produce to try to provide additional power. So those issues with reliability are exactly addressed in this, but also resilience, which is another thing. Reliability is how much can you actually rely on this source to provide electricity. Resilience is how fast can the source get back up after a major event, like a major storm or something like that. And so in both of these cases, whether you're worried about reliability or resilience, the real value to our grid, at least in the past and certainly continuing in today, has been provided when you have large baseload generators like nuclear or combined cycle natural gas that are always there and ready to kick in, whether it's cold or hot or windy or sunny or whatever. So the wind and solar can provide electricity that it is used in the grid. It's CO2 free. It does all of those sorts of things. But the problem that we're seeing more and more, we saw it in Texas this year, we saw it in Michigan in January 2019 in the polar vortex. We saw it for the past 2 summers in California. when they had rolling blackouts. We saw it in Washington State in November 2019, where they went for a week, literally with almost no wind resources. All of these sorts of things are starting to build. And like Brent said, the more that we rely heavily on renewable, we're starting to see these reliability and resiliency impacts grow.
Good. And I want to, before I get to our next question, I want to thank our many attendees for putting in valuable questions, and we'll be continuing to work through those. And my next question will be for Brent. It's a two-part, and I'll have Jason address the second half. But Brent, many media and other outlets are claiming that shortages in natural gas supply were the primary reason for the Texas blackouts in February. First off, is this actually the case? And secondly, can you explain how increasing our reliance on renewable energy will also increase our reliance on natural gas?
Yeah, it's kind of that talking point has been kind of used to obscure a lot of what's really the problem, right? So I was talking with my colleagues and our advisors days before the event, saying that we were going to be short on capacity, right? We don't have enough dispatchable capacity to handle this event. So that was before any of the weather problems that happened, right? The problems that we had with our natural gas supply, with power plants that didn't work properly, those were real problems and they need to be addressed. But those just made the problem worse. We were already going to have blackouts, and the failures that happened just made it worse. So I think it needs to be understood that, and this has been a hard point to get across to people, that this was inevitable, and it's going to be inevitable in the summertime as well, even when all our power plants are optimized and performing great. So there's a market design problem that we're facing, and it's not being addressed, right? And so, yeah, you're right that it is going to require more natural gas if we're going to have renewables. And if we don't balance the market, then what we need is a lot of fast ramping natural gas to handle the variations, and we have to pay for that. And it's going to be expensive. I mean, our models show that, you can get to 50-80% renewables, and you're still going to need almost as much natural gas as we have now, even though you're adding all these renewables, right? So we have to maintain this backup power at all times, right? It's only once you get beyond 80% that you have to start cutting that out and then adding batteries, which is incredibly expensive, right? So it's really a big problem that we're not addressing. We're just adding renewables without doing anything to counter it. So that's going to be, it's just something that we have to address. And we're finally, I think, now getting the conversation around in Texas to actually what can we do to address this problem, and not just focusing on what failed during the storm, but actually what do we need to do to fix the market.
Sure. And Jason, I'd just like you to touch on the second half of this question. What implications does that increased reliance on natural gas have in situations like the February 2021 rolling blackouts in Texas or the January 2019 polar vortex event here in Michigan?
Right. Well, the issue is that, like as we've kind of touched on, when the sun doesn't shine, solar panels are not producing electricity. When the wind doesn't blow, wind turbines are not producing electricity. So you need something to pick up the slack. And Brent used a term, it needs to ramp quickly. So ramping refers to the ability of a natural gas or some other source of energy to come online very fast and start producing electricity. And so probably the absolute best generation technology for that is large hydro, because it can go on and off immediately. They can just turn on or off because the rattle's just there waiting. So after that, the next most reliable is something like natural gas. And there are different forms of natural gas. There's internal combustion engines, there's simple cycle, there's different types combined cycle that are there. So typically what you want is a simple cycle, which is just a single turbine that runs on natural gas, or an internal combustion engine. It's like the engine in your car. and it can just basically turn on and start producing really quickly when wind speeds drop down below a certain amount, or if solar stops producing at the end of the day, those kind of things. And so to kind of explain a little bit further, I saw one comment that said that solar panels that only produce for 3 or 4 hours a day are poorly designed. I was speaking specifically about the month of January in Michigan, when clouds and all of those sorts of weather conditions make it so that it's not going to produce. On balance, as a general average, solar panels produce they have a 20% capacity factor. In Michigan, last year it was 16.3%. So that's just because the sun only shines for so long and the rest, the clouds go over and those sorts of things. But when that happens, when solar panels are not producing, you need something like natural gas. And so it's kind of an amusing sort of ironic situation that the more renewable energy that we build, the more we rely on natural gas. So you cannot escape the two until we come up with something like better battery technologies. But as Brent and I have already talked about, batteries right now are extremely expensive. And then another comment from one of the attendees was discuss the environmental impacts of building these batteries. So right now in the United States, we don't really produce a lot of the chemicals or the metals or the minerals that we need to make these batteries. And so mostly we rely on China to produce those. And so what we're doing in an environmental sense is we're just offshoring the pollution and the mining and all that sort of stuff that's associated with getting the rare earth metals, the lithium, the cobalt, all of those kind of things. And so right now China is dealing with that environmental impact associated with developing those batteries. And we can stay over here and kind of pretend that we're green when really what we're doing is we're making somebody else deal with the environmental impacts. So you've got to have something to back up, and it's just basic physics. Because again, the wind does not blow 24/7 and the sun does not shine 24/7. And when they're not blowing or shining, we need something to provide that power that we all need all the time, 24/7, to make sure our lives continue to operate.
Thank you, Jason. And this next question, I'd like both Brent and Jason to touch on. It encapsulates a number of questions we're getting from attendees. Both of you have critiqued the push to move heavily toward renewable energy. If that's not the best option, what energy sources should Michigan and Texas be targeting? And what generation options should we be building?
I'll answer first of all by saying that, I don't think it's appropriate for us to say we need X amount of this type of generation and this type of generation, that type of generation. That's a government solution, right? We need to create market structures that value that appropriately price the things that we value, like reliability and meeting demand and so on. If emissions are something that we value, then we have to price that appropriately, and then let the market decide what the appropriate mix is, right? So from a physics standpoint, nuclear is by far the most reliable and environmentally friendly source that we have. We've regulated it out of existence because we are overvaluing the safety aspect of the waste, which is not really a big deal from a physics perspective. It's an emotional issue. It's a perception issue that we have with nuclear waste, and so we've overregulated to death and made it impossible to build nuclear. When reality, if we were pricing things properly, I think we would have a lot more nuclear, right? So I think that's the job of the regulators, and also in Texas now, it's really our job is to set the market so that it decides on the correct balance of resources. And we see entities in Texas, vertically integrated entities, that are doing this. And they have a diverse mix of resources that meet their customers' demands, right? The problem is the market as a whole is not doing it. So we see examples of how it can be done, and we're trying to expand that to the rest of the grid. But it's really a challenge because we're not valuing things properly.
That answers, like Ed asked a question, in the Q&A, is the market out of whack in Texas? The market's the way that, like, and the thing that Brent keeps hammering on is exactly right. In an electricity market, what is happening is you're chasing the lowest cost provider and just paying for the electricity when it's produced. And so you're not valuing any of the other aspects of the grid. What we've been doing really is living on invested capital from the 50s, 60s, 70s, 80s. And so the reliability was there because we had the big coal plants, and Texas doesn't have as many nuclear plants, but it has some. We've been living off of the reliability, and again, that invested capital from decades before. And what we're doing now is we've set up market, in quotes, market signals that rely, or that really they encourage things that we aren't really that we should really want, like just necessarily having the cheapest price for electricity, but forgetting that we want that electricity to be reliable is a problem. You want to actually provide market signals that encourage reliable, affordable electricity, not just cheap electricity, because you may pay almost nothing for that cheap electricity, but you don't know that it's going to be on tomorrow at 3 p.m. You just like, well, it was cheap, but it's not here when I need it. And that was the case in Texas, again, in February. You know, the electricity up to the point where it got cold was cheap. I mean, if you look at the difference between prices, electricity prices in Texas and adjacent states, or electricity prices in Texas and compared to Michigan, well, Texas's electricity prices are less expensive. Michigan pays a much higher rate. But one of the reasons we pay that, apart from the fact that we don't have a market electricity, we have monopoly utilities that control the provision of electricity, and there's no competition at all. But part of the other reason is that the utilities up till now have kind of added in a surcharge to say, look, if we're going to build something, we want to know that it's here. And so they build in something that's called reserve factors. So you want a reserve factor typically of around 15% for your market. So if you think you're going to need 100 gigawatts, you're not going to need that. That's just a number. But if you're going to need 100 gigawatts of supply, then you're going to build 115 just for, like, again, you want that 15% reserve factor. And so what happened in Texas's market over several years, like over a decade plus, is they started chipping away at those reserve margins, and they built more and more wind. So wind actually now is the second largest provider of electricity in Texas, and it actually took over the second place from coal. So while you're closing coal, you're building wind, you're valuing that cheaper, less expensive electricity, but you don't know that it's reliable. So that's part of the problem.
Can I add a couple things to what Jason said? Because he basically just encapsulated everything right there.
Yeah, and Brent, before you do that, I'll add this question goes into what both of you have touched on, but just in your answer, if you could address how much of the Texas crisis was a result of line loss on the grid versus loss of renewable energy production.
Yeah, so to that point, we did have some outages due to transmission, freezing and things like that. It was pretty minor, I would say. So that really wasn't a huge issue. And the loss of, we say the loss of renewable energy production. Well, there's two things that went on, right? You have the operational issues. You have machines that weren't working, and that was both, thermal and renewable. We didn't have generators that were working, right? But with the renewables, you also had the loss of the resource, right? You didn't have, the wind wasn't blowing enough, right? So that so we had the operational failures, but the real failure was the failure to plan for what we knew was inevitable, which is that when you have a big winter storm, you're not going to have, once the storm passes, you don't have much wind. and you have very little solar. They actually had decent solar during the coldest parts, which is somewhat unusual. So it was a failure of planning. Now back to what Jason said, when you hear about wind and solar are cheap, what you're referring to is what's called the levelized cost of energy, which is basically how much does it cost to build a generator when you amortize that cost over the life of the plant and subtract out how much you get from electricity for it, right? So it's really a cost of how much does it cost to build a generator, right? It doesn't measure how much does it cost to actually provide the electricity as a service, right? Electricity is a service. It's energy when you need it, right? So within that, there's transportation of the energy, there's storage of it, and there's distribution, right? And so in all those other factors, wind and solar are far more expensive, right? Gas, coal, all these other resources, they're also intermittent in the sense that we don't have them. Like, it's not like we just have a continuous stream of coal or natural gas that's just sitting right next to the power plants, right? They have to be transported, they have to be stored. In Texas, we don't store much natural gas because it's right underneath us. We have it sitting on an ocean of it. But in the north, y'all store a lot of it. And so it's really cheap to store those fuels. That's really the difference between. So when you hear people saying, well, wind and solar are really cheap, well, they are cheap to produce electricity, but they're not factoring in how expensive it is to transport it and to store it, right? And if we're going to have, nationwide renewable energy, we need to build tons of transmission lines and tons of storage that do not exist now. So that's really the crux of the issue. So don't let people fool you when they talk about how cheap wind and solar are, because they're only cheap to generate, and we just saw that in Texas, right? We've been generating a lot of cheap wind and solar, but now we're paying on the back end because we lost power when we needed it. So now we have to correct for that, and so it's not, in the long run, it is not cheap because you pay for it in reliability.
Sure. Thanks, Brent. And this next question could warrant an entire event series on its own, but I would like Jason to touch on, in the theme of reliance on certain capacity for energy, does Michigan rely on the pipeline that Governor Whitmer and General Nessel are trying to shut down? I believe that's in reference to Line 5.
Yeah. So it's a little bit different topic, but yes. So what Line 5 provides, and especially for Michigan, primarily the big issue is around the supply of propane. So that kind of fits into the same framework that we're discussing, because somewhere in the nature of, I think it's 8 to 10% of Michigan households rely on propane to heat their homes, to cook their foods, and do those sorts of things. So yes, Line 5 provides 55% of the propane that's used in the lower peninsula and 65% of the propane that's used in the upper peninsula. And so the concern about that is Governor Whitmer has mandated closure. She's revoked the easement agreement. That's the contract that allows Enbridge to operate Line 5 through the Straits of Mackinac. And so she did that because she's concerned about an oil spill in the Great Lakes, as pretty much anybody is. I don't know of anybody who would be ambivalent to an oil spill, but essentially Enbridge has said we need to continue operating the pipeline until we get a tunnel built underneath the bed of the Great Lakes that will allow us to move the pipeline into the tunnel. And so Governor Whitmer and Attorney General Nessel have both worked to revoke the right of the pipeline to exist, and in many ways have been kind of stalling the process to build the tunnel. The tunnel really is a win-win situation for everybody because it protects the Great Lakes, it gets the pipeline out of the water, but it also maintains that essential infrastructure that provides propane to 55% plus of the state. And then at the same time, for people who aren't aware of it, it also ships light crude oil that comes from the oil sands in Alberta in Canada. And that light crude is used in refineries in Ontario, Quebec, and Ohio, and also in Michigan to produce a mix of transportation fuels, the gasoline that you use to drive your car every day. It's, I believe, 75% plus of the jet fuel that powers the Detroit airport, and I think 100% of the jet fuel that goes into Toledo's airport. So it's used in a wide variety of sources across the Midwest and throughout the entire region in Canada, in Ontario and Quebec as well. But yes, very definitely Michigan relies on that pipeline.
Thanks, Jason. And you both touched on the problems of government often facilitating the monopolization of utilities. And this next question echoes the concerns of many other attendees as well. Why is the Michigan Public Utility Oversight Function allowing for the shutdown of natural gas, nuclear, coal, et cetera, which means ratepayers and Michiganders are all vulnerable? So what are the motivating factors behind that? Why are those decisions being made?
Well, the primary reason it's being done is concerns about climate change. That's the main reason why, which leads us to the next question of, okay, if we're concerned about climate change, why would we be shutting down nuclear plants like the Palisades plant? Because nuclear, as Brent has already said, is the safest, the most reliable form of electricity. And on top of it, it produces no greenhouse gas emissions when it's producing that safe, reliable electricity. Now, nuclear is when you're building it. Right now, based on, again, something that Brent said, that it's been regulated to the point where it's almost impossible to build it, and it's exceedingly expensive to build it. But the plants like the Palisades plants already exist. They are already built. They are already paid for. And so the notion that we would be closing down an 800 megawatt supply of greenhouse gas free electricity when it's already paid for is just, I mean, it's really beyond me. But again, you will hear the arguments basically that say, okay, well, it's too expensive to continue operating this plant, that wind and solar are less expensive. And then we go back to, again, something that Brent had already said is, it's only less expensive if you're focusing on that levelized cost of energy, or the LCOE, when you're not taking into account the imposed costs of solar and wind on the grid, the fact that you need to back them up and effectively need to build, when you build 1 megawatt or like a 2 megawatt turbine, wind turbine, you have to build essentially almost 2 megawatts of natural gas to back it up. So you end up building the system twice, and you end up building new transmission and all that sort of stuff to cover and make it so that wind and solar can be reliable, instead of just saying, why don't we keep places like the Palisades nuclear plant? And then as we move forward, the next thing that we should be focusing on is what's called Gen 4 nuclear technologies, the small modular reactors, the thorium salt reactors, the molten salt reactors, those sorts of things. We should be focusing on building those because they will provide the fail-safe. Like some of the arguments you hear against nuclear is that people are worried about Fukushima, that could happen again. Well, the new Generation 3 Plus technologies and the Gen 4 technologies are built to avoid the problems that Fukushima or Chernobyl or others had. They're built specifically to stop those problems and to do it reliably. And even when you take into account something like Chernobyl or Fukushima, nuclear is still the safest. It's still the most reliable, and it's still it's just like Brent said, the physics of it just make the most sense. So in every sense, whether it's, deaths associated with the energy source, whether it's emissions associated with it, nuclear comes out, way at the top.
We do have a number of questions too on the the consideration of reliability. So we've talked a lot about the importance and the need for reliable and affordable energy. Where does reliability come into the policy discussion? And then we have a few examples, such as what's been understood as a failure to winterize some renewable functions as a cause to the Texas situation. The letters Consumers Energy is sending to ratepayers saying that rates will go up 1.5 times during peak demand hours. And there's a question on whether anyone on this discussion was aware that Consumers is encouraging people during peak hours to turn on their home generators, which does not seem like a very green solution. Can you speak to some of that on where reliability comes in? If both of you could take that'd be great.
I guess
take a crack. Go ahead, Brent.
Yeah, I'll go first. And yeah, in Texas, really for us, it's been a failure of both the legislature and the PUC to set reliability standards, right? We don't have any kind of really guidance on how reliable do we want our electricity to be, right? I would argue that, it would be almost impossible to get through the February event without some outages, and we wouldn't really want to pay enough to plan for that. We want to pay enough to get through that with some rolling outages that are manageable, right? It's like that's a reliability standard, right? That doesn't exist. We just flat out don't. We tinker with prices and we kind of guess at what we think is the right. The PUC's out there kind of guessing at what they think is the right way to do things, but there's really not a reliability standard that we adhere to. Michigan's, being more of a regulated market has more of that, right? And so I think we need in Texas to really move towards having more of at least some guidelines as far as reliability, that then the PUC can go and meet those guidelines by adjusting prices and market mechanisms and so on, right? And that's probably going to get us to the right balance, but we have to go out and actually do that and plan for it. And that will also, I think, you create market mechanisms that ensure that plants are properly weatherized and so on. Right now, there's not really incentive or money in the market for power plants to weatherize, right? It's very expensive, and it's also counterproductive to do things for the winter and then have to also combat the summer temperatures here, right? In Michigan, you don't have to worry about 100-degree temperatures. We do. And some things like enclosing your power plants, the fluids that you use to lubricate your turbines and so on, those are all different if you're talking about 20 below versus 105 degrees, for us, it's more important to plan for the 105 because we know we're going to get that every year. This was a once in 30-year weather event. So you have to provide some standards and some mechanisms for doing that in order to have the reliability that we want, and we're just not planning for it, right? So you have to create the market around the goals that you desire to meet.
Those goals are key to the discussion because building a system like Michigan has, as compared to Texas's, it's kind of like buying insurance. You can insure your car, you can get the cut rate plan, but you're just like, all I'm interested in is saving money. And if you get in an accident, it's probably going to cost you more than if you bought the gold-plated plan, where you insure everything, uninsured driver, everything you can imagine, you're insured for. Okay, if you get in an accident, you're much better covered if you bought the gold-plated plan, but you're going to pay for it every month. And so those are the questions that you need to answer. What is our goal? What are we trying to accomplish? And to the extent that you're only valuing just, I want the cheapest price for electricity and nothing else, then you're buying that cheaper plan. And if you go into it with your eyes open and you say, okay, well, we could end up with a February 2021 situation, and you're okay with that, well, okay, that's a choice, a social choice you made. But if you go in and you're looking at it in terms of like what Michigan tends to do with its monopoly utilities, its heavily regulated system and all that sort of thing, we pay every single month. Like we have the highest electricity prices in our entire region. None of the other Great Lakes states pay higher electricity prices than we do. We pay well above the national average for electricity rates. And so when something like that happens, we generally tend to be better protected against extreme weather. But even in the case of the January 2019 polar vortex, we still suffered conservation orders. We went to the conservation order stage, not the rolling blackout stage. And so, even when we're paying additional money for this sort of thing and we're buying that more, we're investing more in that insurance package, we still aren't totally covered, because when it hit negative 20 outside, even winterized wind turbines were taken offline because it was too cold for them. We didn't lose any of our coal or natural gas because we had that winterized and ready to go. But again, it's a social choice you're making, and you're saying we want to invest in insurance or less expensive prices.
I know we do have limited time, and I appreciate the great discussion here and all of the questions. I apologize for those we couldn't address here while we were live, but we'll do our best to get back to you one-on-one. One last question. I would like each of you to take just 45 seconds or so just to share what the Mackinac Center and organizations like Life Powered are doing at the state level to counter some of the government monopolized utility tactics and the agenda that's not in favor of reliable and affordable energy.
I'll talk about what's going on in Texas, which is that we are now finally having the discussions that need to be had about how much reliability do we want, and how are we going to pay for it? Because up to this point, all we valued is just cheap energy, and then we have the federal subsidies that are overvaluing emissions reductions. They're pushing the equilibrium towards emissions reductions over reliability, right? And so we really are now finally having those discussions about what actually do we want. And so that's an encouraging sign that's come out of this event, is that there's now space for those discussions where there was not before. We were just pretending that we could just go this direction and nothing would happen. And so I think that it's incumbent upon Michigan not to make the same mistakes. Like you're at a point now where our grid was at least a decade and a half ago, where you're making these considerations about, do we want more wind and solar? And I've had this discussion with regulators in Indiana as well, and legislators there. You got to think now about looking at Texas. Do we want to go there? Do we want that much wind and solar? If so, how are we going to maintain reliability, and do we want to pay for that? It's an important question, and hopefully now we can have those questions and bring some balance in the market, because where we're going right now is breakneck speed toward unreliable wind and solar, and there's just it's scary to think what could happen in the next few years if we don't fix things right now.
And Michigan is where Texas was like 7 to 10 years ago, and we're doing the exact same thing. All of our utilities are saying we're going to close down existing coal plants. We're not building new coal, but we're going to close down the coal plants that we have. We're going to close down a bunch of our natural gas, and we're closing down one of our nuclear plants. And so what are we doing? We are constantly talking with legislators, with anybody who will listen, really. We're talking with, and then we're also prepping to get involved in Public Service Commission dockets, whether it's rate cases or integrated resource planning, the long-term planning processes that help set the tone or the framework for where Michigan will be over the next 20 years. And we're arguing strongly that we should be focusing on building more nuclear and natural gas instead of shutting down everything that is reliable, as we've already talked about, and going for what even wind and solar defenders call reliably unreliable electricity sources like wind and solar. So that's where we're going, and I know we're out of time, so I'll stop there.
Thank you, Jason. And I want to thank Jason and Brent once again for joining our discussion today and making this possible, and thank the number of attendees who registered and and attended and provided such great questions for this discussion today. If you would like to share this event or know someone who wasn't able to make it who may be interested, that will be available in the coming days at mackinac.org/events, along with prior virtual events as well that you can view and share at no cost. And I want to thank all of you again for attending. Looking for future events in your email and on our website, mackinac.org/events again. And just a reminder, the Mackinac Center is a 501c3, and we exist and are able to put on events like this and advance sound public policy because of the generosity of individuals, foundations, businesses. And if you are open to supporting the Mackinac Center, and we appreciate that, and thank you for those who have in the past and continue to do so. We look forward to continuing this discussion at a later date and future events. Thank you all for your time.